start into synthetic division. We'll pick this up again tomorrow, time permitting. But in your textbook, we're on pages 29 to page 30. All right, we've done some long division, and I know that we'll probably have to back up and review some of that long division. Synthetic division is a faster way to execute that you can execute long division in certain situations. It doesn't work all the time. Now, whenever the divisor is in the form of, as it is pictured in your book, when the divisor looks like this, x plus or minus a, sometimes x plus or minus c. You know, that being a is some constant, right? Like 1, 2, 3, or 4. X, as you and what I mean by x here, not raised to the second power or the third power, generally speaking, but raised to the first power. The coefficient of x is a 1. All right. When your divisor it looks like this, then you can do a compact form of division called synthetic division. And the way it would work basically is like this. There's an example problem in your book. And the way this works, x to the 4th plus x to the 3rd. Just going to write the problem down. Okay, this is your problem on page 29 in your book. This is referred to again as your dividend. This is your divisor. The divisor in this situation here, in this problem, is of this special form, x plus or minus a, where a we identify as 3, and then, well, x is what it is. Now, so what we're going to do is this. Synthetic division works like this. You're going to take the 3, and just follow with me and let me explain what's going on. I'm going to change the sign on that minus 3 and turn it into a plus 3, all right? If it had been an x plus 3, I would have put a minus 3 in this little box here. Now, out to the right of this little box, what I'm going to do is write the numeric coefficient all the way down to the last term, 30, which is a constant term, carrying the signs with it all the way across. 1, 1, negative 3, negative 17, and 30. All right? Those are the coefficients. Now, what I'm going to do here with this problem, first thing I'm going to do is I'm going to bring the 1 down. The lead term, the coefficient of the lead term in my dividend, I'm going to bring it down here. All right? You may have a lot of questions as to how and why this works the way it does. Just short time being what it is, just accept it. Bring the 1 down. The process I'm going to go through is I'm going to say 3 times 1 is 3. I'm going to tag the 3 or put it up underneath the second term in my problem. I'm going to add those 2 up and get 4. Okay? And I'm going to say 3 times 4 is 12. Place it up underneath the negative 3 and add it to that negative 3, which should give you a 9. 9 times 3 is 27. Place it under the negative 17. Add those. The difference, 10. 3 times 10 is 30, and I should have put a negative by this 30 because it's a negative up here. 30, they cancel 0. Now, what these numbers represent are the numeric coefficients in your answer. And every time in a synthetic division problem, the lead term in your answer is going to be 1 degree less than the lead term in your dividend of your problem. So if the problem began with x to the 4th, 1x to the 3rd will be the lead term in your answer for the quotient, plus 4x squared plus 9x plus 10. What is that, 0? Well, that's the remainder. Whenever there's a 0 out here, there's no remainder. If there was a number here, we'd have to treat it like we would a long division remainder, where we would have to set that up as whatever that number ended up being as a fraction, with the denominator being the divisor and the numerator being whatever number you see there. I like it when there's no zeros or when there's no remainder, so that there is a 0 there, and this becomes your answer. Okay? Piece of cake, right? Right. Was that confusing?
Were you being sarcastic?
Pretty much.